Hi guys, welcome to the lesson of partial differential equations. So after discussing the classification and canonical forms of second order partial differential equations, now we are moving towards solving some great classical partial differential equations, some phenomenal work by the great mathematicians of that time: Fourier, Laplace, D'Alembert, and many great mathematicians, right? So for that, what we need is we need to be very much familiar about the Fourier series, because Fourier series is going to be used in solving the partial differential equations for equating the initial conditions with the solution of the equation, right? So what is Fourier series? You all are familiar with the Taylor series. The great Taylor series is used to express any function in terms of polynomial, or we can say that in the powers of x. So the Fourier series is used to express functions in terms of sine and cosine, right? So why we need this Fourier series? The answer is very simple. This series, the in signals and systems where we have any function of time, the frequency, like if the frequency is given by some function of time, and we all know that f is equals to 1 over t, where t is the time period. And now we want to see the behavior of this signal, so we convert this function of time. We can convert actually this function of time to the sine and cosine for observing the behavior of this uh, period, right? So it's mainly used in the signals and systems, and it's used in solving partial differential equations. So there are a lot of uh, there may be a lot of other applications in other fields, right? So if a function f of x is given, we may express the function as f of x is equals to a naught divided by 2 plus summation n runs from 1 to infinity times a n cos 2n pi x over b minus a plus bn times sine 2n pi x over b minus a. And this b minus a is interval in which the function is defined, right? So say if a and b is negative pi to pi, for example, then the series will be f of x is equals to a naught over 2 plus summation n runs from 1 to infinity a n cos 2n pi x over pi minus negative pi. This is b and this is a, right? So pi minus negative pi, here also pi minus negative pi, so it will be 2 pi, and 2 pi and 2 pi will be cancel out, and we will only left with this equation, right? So this is also called the general Fourier series for period 2 pi. Whenever the period is 2 pi, we can use this series, right? Either the period may be from negative pi to pi, right? So again, it's 2 pi. Either the period may be from 0 to 2 pi. Again, it's the period is 2 pi. Either the interval may be from pi over 2 to 3 pi over 2. Again, it's 2 pi, right? So whenever the period is 2 pi, so we can use this series, right? Same is the case for the interval 0 to 2 pi, right? So in general, we can say that if the interval a comma b is equals to negative L to L, so b minus a will be equals to 2L, and then f of x is equals to a naught over 2 plus sigma n runs from 1 to infinity a n cos n pi x over L, because 2 cancels with this 2 here, and sine n pi x over L, right? Actually this is 2n pi x over 2L, where 2 is cancelled out with 2, right? Because the period is 2L. So same is the case when if a comma b is equals to negative 1 to 1, then b minus a will be 2. And when we will divide 2 and pi x over 2, so we will 2 and 2 will cancel out, we will left with n pi x and n pi x, right? So you should be familiar with all this stuff. I'm using different intervals to make your concepts stronger, so you may not get confused in the exam or in the given question, right? So if a comma b is negative 2 to 2, the interval, so the period will be b minus a is equals to 4, so we'll put here 2 and pi x over 4, so we will get n pi x over 2, right? So here is the n pi x over 2. Similarly, if it's from 0 to 1, it will be, the period will be 1, so 2 n pi x divided by 1 will be 2 n pi x itself, right? So this is 2 n pi x. So in this case, you can see that for many other intervals you can drive it, right? It's not that difficult. Now we will talk about the coefficients of the Fourier series, very important. So coefficients are a naught, a n, b n, right? So how to find the coefficients? So this is the formula for finding the coefficients. You can see that this is nothing but just we are integrating the function whenever a function is given in an interval. Whenever a function of x is given in an interval a comma b, so this is the formula to use, right? These are the formulas for the coefficient. 2 divided by b minus a, integral a to b, f of x dx. And for an, 2 over b minus a, integral a to b, f of x cos 2 n pi x over b minus a, right? In the similar manner. And bn is equals to 2 over b minus a, integral a to b, f of x sine 2 n pi x over b minus a. Right, so these are, in this way you can find the coefficients and then plug back to the original equation, that is we have written f of x is equals to a naught over 2 plus summation n runs from 1 to infinity a n cos 2 n pi x over b minus a plus bn sine 2 n pi x over b minus a, right? This. So when we put the respective values of a and b and a naught, we will generate a Fourier series of a function x in terms of sine and cosine, right? And these are the important points to remember for future, that cos n pi will be equals to negative 1 to the power n. Like we will substitute wherever we will see cos n pi, we'll substitute with negative 1 over n. And for sine n pi, we will use 0, right? Because sine is 0. Sine pi is 0, sine 2 pi, sine 3 pi, sine 4 pi, dot, dot, dot. So sine n pi is equals to 0, right? Now we'll take some examples. Let's say we are asked to find the Fourier series of x squared. So what we are going to do is, first of all, we will check the interval. Interval is from negative pi to pi. So the period will be 2 pi, right? So the series now that will be generated will be like this. Cos n x plus b and sine n x, as I told you earlier in the lesson, that for 2 pi, it will become cos nx, because actually it's like this. And when we will divide it by 2 pi, this will cancel out with this, and we will only left with cos nx, right? So here is cos nx, and similarly sin nx, right? And then for the coefficients, a naught is equals to 2 over b minus a, so b minus a is 2 pi. 2 and 2 will cancel out. We will left with 1 over pi, and the integral of x squared will be x cubed over 3, right? From negative pi to pi, you can apply the limits. So you can apply the limits and you will find the answer, right? And similarly here, it will be 1 over pi integral negative pi to pi x squared cos nx dx. So you can apply the by part rule and find an, right? And for bn, similarly, this 2 will cancel out with this 2, negative pi to pi x squared sine nx dx, right? So whatever the values are, at the end you just have to substitute like this. F of x is equals to a naught. For example, in this case we can see that a naught, if we want to find, let's find this, it will be pi cube over 3 plus pi cube over 3. So it will be equals to 2 pi squared over 3, right? If I'm not wrong, pi cube plus pi cube will be 2 pi cube, and pi cancels with pi, yes. So we can write here that a naught over 2, so 2 pi squared over 3 divided by 2 plus summation n runs from 1 to infinity. Whatever the value of an you get from this integral, you can substitute here, right? And whatever the value of bn you get from this integral, solving this one, you can write, and just we have to multiply by their respective functions, that is sine x and cos x, and this positive sign in between, and this will be the final answer, right? So you can derive the answer. I haven't solved any problem. I just have solved the initial steps for you, because I know that you are very good in integration. You can solve the integrals is quite easily, right? So for this function, you can see the interval is in 0 to 2 pi. So the period will be b minus a to pi. Then again, this will be cos nx and sin nx. So same steps, a naught is equals to 2 over 2 minus b minus a. This will cancel, this will cancel, this will cancel, right? So here we will get e to the power x 1 over pi from 0 to 2 pi. So you can solve it further. Similarly here, it's 1 over pi. This implies that integral 0 to 2 pi e to the power x cos nx. You can check the integral of this function. You can directly write its integral is given in the books. You can check, and for this we can write it like this, right? So we can solve, and then we can write the solution here, that f of x is equals to whatever the value of a naught is, and whatever the value of an is with cos nx, plus whatever the value of bn is with sin nx, right? Similarly, this is a piecewise function, and you can see that uh, now how to calculate the Fourier series. Okay, to find the period of this function, basically we need to check the least and the greatest interval, right? So b will be equals to 2 pi, A will be equals to 0, right? In every problem of this type, whenever you are given a piecewise function, you have to check the greatest value and the least values, right? So you should be aware for selecting these intervals, right? So b minus a is equals to 2 pi, right? So again, the series will be generated in this manner. We talked about this series in previous problems. Now, how to find the coefficients? It's a similar manner, 2 over 2 pi into integral of, now it's piecewise, so we will integrate it piecewise, right? First from 0 to pi, and we know that the value is k minus x, so we applied k minus x, limit 0 to pi. Then we know that from pi to 2 pi it's x, then from pi to 2 pi it's x, right? So it's obvious from the question that we have to apply the integral piecewise, right? And similarly for an, right? K minus x times cosine nx from 0 to pi, then x times cosine nx from pi to 2 pi, right? And similarly for bn. So you can see that it's not a very tough phenomena. It's simple, and you just have to be familiar with the integration. You should have a good command on integration, right? And then you can write the final answer f of x in terms of the series a naught a and bn with the sine and cosine term, right? Again, it's a piecewise function. So now, what's the least? What's the greatest? So b is equals to pi over 2, a is equals to negative pi over 2. So b minus a is equals to pi. All right, so now the series will be like this, because cos 2 and pi x divided by pi and pi will cancel out. We will left with cos 2 and x. Similarly for sine 2 and x, right? So here it's sine 2 and x and cos 2 and x. And the coefficients will be found in the similar manner piecewisely. From negative pi over 2 to 0, it's 0. So we applied 0. From 0 to pi by 2, it's cos x, it's cos x, right? So we can found like this. We can find it like this, sorry. So this is 2 over pi. Why 2 over pi? Because it's actually 2 over b minus a, and b minus a is pi, right? So you can refer here, right? Again, for an, we will apply the piecewise integration. Negative pi to 0 is 0, so this whole will become 0 when multiplied by this 0. And again, for 0 to pi over 2, it's cos x times cosine 2 and x, and we will integrate this function. First of all, for integrating this function, you should be aware that cos alpha, cos beta in the summation form, right? From product form to sum form, you can apply the trigonometric identity for this. Cos alpha cos beta is equals to some addition of these cos or sine alphas, right? So you can see in the books, you may found there. So you can solve this integral by converting, actually transforming from the product form to summation form, right? Similarly for bn, here you can do the same. It's cos alpha sine beta. So you can see in the books what is the form of this from product to summation form, right? So it will be solved easily, right? So, and you can write the final answer a naught a and b, and right here again it's a piecewise function. Method is same, greatest value and lowest value. So a is equals to -2, b is equals to 2, so b minus a will be equals to 4, right? So then cosine of 2n pi x divided by 4 now will be cosine of n pi x over 2, right? Similarly, sine of n pi x over 2. So here are these cosine n pi x over 2 and sine n pi x over 2, right? So the series will be in this form. And again, for a naught, 2 over n b minus a, b minus a is 4. All right, and we will apply the integrals piecewisely. So from -2 to -1 is 0, so it will be 0. For -1 to 0 it's -2, then 0 to 1 it's -1, oh sorry, +1, then from 1 to 2 again it's 0, right? So we'll apply the integral in the similar manner for an and bn, and then we will generate a series like this, okay, by solving these integrals. So you should solve these integrals. I left this to you to solve these integrals and to generate the final answer, right? It will be like practice for you. And then again, it's a piecewise function from -5 to 5. So a is equals to -5, b is equals to 5. All right, so similarly, you can see that the period is 10. So if the period is 10, then this will look like this. And now you are very much familiar how this is found: cos n pi x over 5 and sin n pi x over 5, right? So 2 over b minus a is 10. Then applying the integrals piecewise for a naught and similarly for an, right? You can see this. And then similarly for bn. And at the end, we will generate a series, right? Now in this question, you can see that it's x squared minus kx, limits from -2 to 3. It's a general interval, right? So similarly, b minus a is equals to 5. So similarly, cos 2n pi x over 5, it will be, and sine 2n pi x over 5, it will be, right? So here it's like that. And for a naught, 2 over b minus a is 5. Limits from -2 to 3 as given in the intervals, and this function, right? For a, and again 2 over b minus a, limit -2 to 3, the function times cosine 2n pi x over 5, right? Again for bn, it's the same, limits -2 to 3. Okay, so you can solve these integrals very easily. Now this is very important function. It's a modulus function, right? So for modulus function, the first thing you have to do is you have to break the intervals, because modulus function means that it's negative as well as it's positive, right? In some interval it's negative and in some interval it's positive. So the interval is given from -pi to pi, and we can see that from -pi to 0, x will be always negative, right? And from pi 0 to pi, for sure x will be positive, right? So now this is a piecewise function. It's kind of a piecewise function, right? Kind of a piecewise function. So we break this function like this because we cannot solve the mod function directly, and the interval is 2 pi. Therefore here it's nx and nx, right? So now we can solve it like a piecewise function. We already did in the previous questions, right? So you can solve it easily. It's not a difficult task, right? Using piecewise. Here it's a naught 2 divided by b minus a, that's 2 pi. -pi to pi is -x. 0 to pi, sorry, -pi to 0 is -x. 0 to pi is positive x, right? Again for an, same manner, just with cos, cosine. And for Bn, integrate with sine, the product of a function and the sine, right? So in this manner, you will generate a series. F of x is equals to like this, right? Then again, some modulus function again, sine x. So for sine x also, for sine negative x, we know that it's always sine negative sine x, right? So sine from negative pi to 0 will be negative sine x, right? And from 0 to pi, it will be positive sine x, right? So again, we will break this function into piecewise. And remember, we have to break every odd function, because for odd functions, we know that odd functions are like f of x is equals to negative f of x, right? Sorry, f of minus x. F of minus x is equals to negative f of x. So we need to do this, that we break the intervals, right? To find the appropriate series. So sine x is an odd function. Similarly, x was also an odd function, right? So we will break this negative sign when x is from negative pi to 0 and positive sign when x is from 0 to pi, right? So the series will be generated in this manner. The interval is negative pi to pi, so it will be period will be 2 pi. So this will be the series. And similarly, you will integrate in the intervals, in the piecewise intervals, negative pi to 0 is negative sign, 0 to pi is positive sign, right? Similarly, for n and bn, we can do in the similar fashion, right? Sine, negative sine x times cosine n x, then sine x times cosine n x. First is from negative pi to 0, second is from 0 to pi. Right, so similarly for bn, so in this case, again, the series will be generated and you have to solve all these questions, right? Now it's a piecewise function and you can see that the interval is from negative pi over 2. It's negative pi over 2 to 3 pi over 2, right? So b is equals to 3 pi over 2, a is equals to negative pi over 2. So b minus a will be equals to 3 pi over 2 plus pi over 2, that will be 2 pi, right? And let me do a correction. In the beginning, I just did a mistake. Here I wrote that it will be from negative pi to 3 pi over 2, right? It will be negative 3 pi. So this will become, the period will become 2 pi. Otherwise, the period will become pi, right? So you need to make a correction here. So again, we are done with modulus functions. And here it's the interval, the period is 2 pi, rest of the steps are same, you can carry on, right? So important points are, as we discussed above, that remember whenever modulus function is given, check whether the function is even or odd, right? If it's odd, you have to break the interval. If it's even, it's fine, you can integrate it, right? As it is, we don't need to break the interval. So x is odd, therefore we will break the interval like negative, but then this, if the interval is given like this, then we'll break like this, right? Similarly for sine x, we break the interval, right? And for cosine, you can see since cosine is even, so no need to break the interval, right? You can integrate it from negative pi over 2 to 3 pi over 2 cosine x dx, right? Uh, if we are asked to find sine or cosine series only, then don't need to find the whole series, only find whatever is asked. Like if they are asked, they have asked in the question that find the Fourier sine series of the function. So you only need to find the sine from the series, right? You don't need to calculate a naught and an. You only need to calculate bn then, okay? For sine series, it's bn. And for cosine series, it's a naught and an. And in generally Fourier series is the sum of cosine and sine series, right? So hope you get this point, right? So if we are asked to find the sine series, so the series will be given by this, right? You have to calculate bn. You need to calculate bn only. And for cosine, you need to calculate a naught and an only, right? So we don't need bn here. Now, very important topic is the convergence of Fourier series. Now, what it says that at the point of discontinuity, the Fourier series will converge to the average, right? To this average. Now we'll solve a problem how this converges to this average. Let's say we are given a piecewise function, the point of discontinuity is 0. You can see that. So here 0 is the point of discontinuity. So for f0 plus plus f0 minus over 2, this will, the series will converge here, right? And we will check in the later part how it's right. So f of 0 will be pi minus 0. Here we will put 0, right, for 0 positive, right? This is the positive interval. So f0 positive will be pi minus 0, and this is the negative interval. So it's 0 anyways. We don't need to write anything. It's 0, right? So now f of 0 plus plus f of 0 minus. So pi minus 0 plus 0 over 2. So this integral will converge at pi over 2. This means that f of 0 is equals to pi over 2. Now we will check that either if it's true or not. So at f is equals to 0, the point of discontinuity, the series converges at pi over 2. Now let's check this. So here it's written that so the series for a given function will converge to pi over 2 at x is equals to 0, right? So notice that the solution of f of x in terms of Fourier series is given by, for that particular function that was given piecewise, the answer of the series is this one. We will solve that function, we will get this answer. Now at x is equals to 0, what will happen? We'll put 0 in place of x everywhere, right? Right, so now f of 0 is equals to pi over 4 plus some summation and runs from 1 to infinity, 1 minus 1 to the n over n square pi cosine 0 plus 1 over n sine 0. So cosine 0 is 1 and sine 0 is 0. So this term will vanish. This whole term will vanish. We will only left with this term, right? For f of 0. Now we know that n is equals to 1, 2, 3, 4, 5, 6, 7 dot 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 natural numbers. So we will apply n respectively. First we will apply n is equals to 1, then n is equals to 2, then n is equals to 3, then n is equals to 4, to n is equals to when n tends to infinity, right? So pi over 4 as it is, this pi over 4 is in the equation as it is, no changes in this. And when we will apply n is equals to 1, we will get 2 over pi. When we will apply n is equal to 2, we will get 0, because 1 minus 1 to the power 2 will be plus 1, 1 minus 1, 0, right? When we will put 3, we will get 2 over 9 pi. When we get 4, when we will put 4, we will get 0. When we will put 5, we will get 2 over 25 pi. Similarly, for every even, it's 0, right? And for every odd, we will get the value. So now we can take out 2 over pi as common, because everywhere 2 over pi is common. So we took out, and then we are left with this in the bracket, and this is equals to pi square over 8, and this result is proved, right? This value 1 plus 1 over 3 square plus 1 over 5 square plus 1 over 7 square to dot 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 is pi square over 8. Notice this result is proved, right? So we can replace this with pi square over 8. Here we did pi square over 8. 2 will be cancelled with this 8, right? 2 ones are 2, 2 fours are 8, and pi is cancelled with pi, so we are left with pi over 4 plus pi over 4, and now we will get pi over 2, right? So f of 0 is equals to pi over 2. So that's what we need to check here, the convergence of Fourier series, and you see that the Fourier series converges to pi over 2 at x is equals to 0. So in the next lesson, we will discuss about the half range Fourier series. Till then, goodbye, take care.